In the previous video, we have seen that what is a character data type in computer and how computers store it. In this video, we will use the character data type in the Java program. Hello everyone, I am Gyan and you are watching the second session of Java and Web, Variables, Data Types and Operators. Character data type in primitive manner is represented as CHAR data type in Java. I will pronounce it CHAR. I don't know what to pronounce it. This is how we declare the variable of character data type. Write the CHAR followed by the variable name. Character constants means character literal are written as only one single character between the opening and closing single quotes. The first three statements are perfectly valid. We can write a single alphabet in between the opening and closing single quotes. We can write a single digit between opening and closing single quotes. We can write special symbols between opening and closing single quotes. So the first three statements are valid here. But we cannot write two or more characters in between the opening and closing single quotes. So these two statements are wrong. We cannot write like this. Let me apply all these statements in a program. The program is stored in the file name firstcharacter1.java and this is the program. We are storing the character capital A in the character variable ch1. We are storing the character small a in the character variable ch2 and we are storing the digit as a character in the character variable ch3. Don't think that 5 is going to store in the ch3. It's little different, we will see in a while. Here the concept is little different, we will see in a while. Then we have printed all these character variables. Let me save and compile it. Java C first character 1.java. Compiles fine and then run it. Java class name was first character, so write first character and it runs fine. But if we try to write more than two characters in between the single quote, then the program will result an error. That means if I write here AB, the two characters in between the single quote, then the program will result error in this line. Compile it and run it. Compiler says there is error in line number 5, unclosed character literal. So we cannot write more than two characters in between the opening and closing single quotes. But we can write special symbols in between opening and closing single quote. We can write here has and it will execute fine. Let me save and compile it. Compiles fine and then run it. Runs fine. It's printing has. So we can have alphabets, digits and special symbols in between the opening and closing single quotes, but we cannot write more than two characters in between the opening and closing single quotes. When we assign a character constant to a character variable, the 16-bit binary of the corresponding Unicode gets stored in it. For the Java program, a memory area called stack section gets created. Inside the stack section, we have a memory area for main. We will call it stack frame of main. And inside the stack frame of main, a 16-bit memory area gets allocated with name C, which contains Unicode of the assigned character. So the Unicode corresponding to character capital A first gets converted into 16-bit unsigned binary, which is this one, and this 16-bit unsigned binary gets stored in the 16-bit memory location whose name is C. Since the character data type is a 16-bit binary location for integer means whole number, you can see this one is a binary pattern representing the character A. Its unsigned decimal equivalent is 65, means the Unicode of A is 65. We can store the following constants means literals in a variable of character data type. We can store decimal, octal, hexadecimal and binary representation of 32-bit integer literal in a character variable. Here we are assigning decimal integer literal 65 to the character variable C. Here we are assigning hexadecimal integer literal 0x41 to the character variable C. The decimal equivalent to 0x41 is 65. Here again we are assigning octal integer literal 0101 whose decimal equivalent is 65 to the character variable C. Here we are assigning the binary integer literal 0b10000001 whose decimal equivalent is 65 to the character variable C. Here we are assigning the character literal, a single character capital A between opening and closing single quote to the character variable C. All the above have same effect. They store the same binary in the variable C. They all store the 16-bit unsigned binary of 65 in the character variable C. Let's apply all these statements in a Java program. We have stored the program in a file name firstcharacter2.java. This is the program, and here we are storing the decimal integer literal in the character variable ch1. Here we are storing the hexadecimal integer literal to the character variable ch2. Here we are storing the octal integer literal to the character variable ch3. Here we are storing the binary integer literal to the character variable ch4. And here we are storing the character literal itself to the character variable ch5. Please notice one point is that all of them represent binary 65. All of them are going to be stored in the memory location whose name is ch1, ch2, ch3, ch4 and ch5, but all these memory locations are 16-bit memory locations, and the 16-bit binaries of 65 are going to be stored in the various memory locations. Then after we are printing all these variables, the program should print the character A 5 times because 65 is Unicode of capital A. Let's run this program. Java C first character 2.java. Compiles fine, then pass it to the JVM. First character, class name was just first character, and runs fine. It's printing capital F 5 times. 64-bit long literal cannot be stored in the character variable. All the statements below cause error. Here we are storing the 64-bit decimal integer literal to the character variable C, which cause an error. Similarly, in the next 3 lines, we are storing 64-bit integer literals in hexadecimal, octal or binary form to the character variable C, and all the 4 statements cause error. Let me try one of them in a Java program and see what the compiler is saying. Open first character 1.java and write here 65L. Let me compile it. Java C first character 1.java. Compiler says incompatible types, possible lossy conversion from long to character in this line. So we cannot store a 64-bit integer literal either in decimal, octal, hexadecimal or binary to a character variable. Now the question is, what is a Unicode constant for a character data type? We take the binary stored in the character variable in the group of 4 bits and represent them as hexadecimal. This is the 16-bit unset binary corresponding to decimal 65 and take them in 4-bit groups. We have 0041 as hexadecimal. After taking them in 4-bit groups, we have 0041 as hexadecimal. If you don't know how to convert binary to hexadecimal, then watch my another video, binary to hexadecimal conversion. The link is given in the video description below. Then after write this hexadecimal preceding with \u in between the opening and closing single quotes. So \u 0041 in between the opening and closing single quote is called the Unicode constant of the character capital A. We can assign the Unicode constants in the character variable as CHAR CH is equal to hexadecimal Unicode preceding with \u in between the single quote. Let me apply this Unicode in a Java program. Open first character 1.java and instead of 65L, write here opening and closing single quote in between \u 0041. Now the ch1 should print capital A. Let me delete all those print statements. Now ch1 should print capital A. Let me compile it. Compiles fine and run it. It runs fine, printing the capital A. So the ch1 stores a value as a Unicode character literal. We take the binary stored in the character variable in the group of 4 bits and represent them as a hexadecimal integer. Writing CHR CH is equal to \u 0041 in between the opening and closing single quote is a Unicode character literal. But writing just CHR CH is equal to 0x41 is a hexadecimal integer constant, hexadecimal integer literal. We can store Unicode character and hexadecimal integer both to the 16-bit character variable. So if I update here and instead of writing the Unicode character, if I write 0x41, then it should run fine. Java C first character 1.java and then run it, it runs fine, printing A. So we can use both the Unicode character literal and hexadecimal integer literal. The difference between the first and second assignments, these two, is that the first one is an Unicode character constant, whereas the second one is an integer constant. One more thing you have noticed that we cannot use the capital U in the Unicode character literal. Let me open first character 1.java, and here we are assigning the Unicode constant to the character variable ch1. Let me compile and run it. Compiles fine and runs fine. Since we are printing only ch1, that's why we got the capital A as output. But if we write here capital U instead of a small u, then you will get an error. Compile it. Compiler says error, illegal escape character. Means compiler is thinking \u as illegal escape character. So we can write a small u followed by the backslash, but we cannot write capital U followed by the backslash. Now it again executes fine. We cannot assign an integer constant in a character variable whose binary representation takes more than 16 bits. Means if we are assigning 70,000 to a character variable, the binary of 70,000 cannot be accommodated in 16 bits. So this will produce an error. So the compiler will throw an error in this situation. Let me update the file, first character 1.java, and first delete these two statements, we are not using them. Right here 70,000. We cannot assign 70,000 to a variable which can accommodate only 16 bits. So this will produce an error. Compile and execute it. It cannot execute because it cannot be compiled. Compiler says incompatible types, possible lossy conversion from int to character. Compiler says that this one is an integer type which you are assigning to a character variable. But if this constant was lesser than 65,535, then you could be assigned it here. Let me apply this. Right here 65,535 and see what's happening. Compiles fine and then run it. It runs fine. Our terminal could not print the character corresponding to that Unicode 65,535. Assigning an integer constant to a character variable stores the corresponding binary in 16-bit location. If we assign a character literal to the character variable, then it stores a binary of Unicode to the corresponding character. Here Unicode of character 3 is 51. So 16-bit binary of 51 gets stored in the memory location whose name is ch2. Look at here, we are assigning the 51 as integer, so the binary of 51 gets stored in the memory location whose name was ch1. And here we are assigning the character constant to character variable, so binary of the corresponding Unicode 51 gets stored in the memory location whose name is ch2. Here we are assigning the integer 3, we are not assigning the character 3. So binary of 3 gets stored in the 16-bit location whose name is ch3. Then after we are printing all these three variables. So for the variable ch1, character whose Unicode is 51 means 3 going to be printed because of variable ch1. For the variable ch2, character whose Unicode is 51 means 3 going to be printed on the screen. For the variable ch3, character whose Unicode is 3 going to be printed on the screen. Let me try this program. Open the first character 2.java. Our program is stored in that file, and here is our program. We are storing the decimal integer constant 51 to the character variable ch1. We are storing the character literal 3 whose Unicode is 51 to the character variable ch2. We are storing the decimal integer 3 to the character variable ch3. So ch1 contains binary of 51, ch2 also contains binary of 51 because Unicode of 3 is 51, and ch3 contains binary of 3. If you print the ch1, then the character whose Unicode is 51 gets printed because ch1 contains binary of 51. If you print the ch2, then the character getting assigned in the ch2 gets printed. Remember that Unicode of the character 3 is 51. Don't think it as a decimal 3. Its Unicode is 51 and the binary of 51 is going to be stored in ch2. If you print the ch3, then the character whose Unicode is 3 gets printed because ch3 contains the binary of 3. Let me save and compile it. Java C first character 2.java. Compiles fine and then run it. Java class name first character. Runs fine. See here, storing 51 in ch1 prints 3 because 51 is Unicode of character 3. Assigning the character literal 3 itself prints 3, but assigning the integer 3 trying to print a character whose Unicode is 3, and that cannot be printed by your terminal. Let's have a formal study of character data type in Java. Character data type in Java used to represent a character data as 16-bit unsigned integer. Each integer represents a separate character from the almost all languages in the world. Size is 16-bit or 2 bytes. Range of the character data type is 0 to 65,535. All of them are not used. This representation of Unicode characters. Unicode can accommodate much more characters than ASCII, which was just 256. Unicode cannot be negative, but with ASCII we can represent a 8-bit integer in both positive and negative way and can be used by C and C++. We can assign following to the character variable. We can assign integer of the range 0 to 65,535 in octal, decimal, hexadecimal or binary. We can assign character constant. We can assign Unicode character constant. So all these assignments are assigning capital A character to the character variable C. Here is the table representing Unicode, decimal and binary of some characters. For character capital A, the Unicode is \U0041 in between the opening and closing single quotes. Decimal is 65 and this one is the binary. That's all for small a. That's all for 0. That's all for the Hindi character A. We spell it A. Unicode is this one, decimal is this one and binary is this one. Let me try printing A. Its Unicode in decimal is 2320. Open first character 1.java and write here 2320. 2320 and then check what is getting printed. Java C first character 1.java. Compiles fine and then pass class name to the JVM first character and it prints A. You can see here a Hindi alphabet gets printed. We can use Unicode /U0910 to print A. Let me use this. Right here opening and closing single quote \U0910 and see what we are getting as output. Compile it and run it. It's again a Hindi alphabet. We can print the Sanskrit alphabet Om, whose Unicode in decimal is 2384. Let me try to print Om. Vi first character 1.java. Right here. (2384) and execute it. Java C first character 1.java. Executes fine, then pass the class name to JVM. Java C first character. Executes fine, printing Om as output. To store the line feed character in a variable, we cannot use the Unicode character in the variable, but we can use the decimal integer literal of corresponding Unicode to the variable. Let's open the file first character 2.java and here we have the program. We are storing the line feed character in the variable whose name is ch1 and we are printing system.out.print hello. We are not using println, so it will not leave the line. We are explicitly printing the new line character to leave the line. Then after we are printing hi with system.out.println. Let me check if we are not writing system.out.print ch1, then how our output is. Comment it out, save and run it. Java C first character 2.java. Compiles fine, then run it. Java first character. And it prints hello hi in the same line. Now let's print the new line character. We are printing new line character and then see what the output is. Java C first character 2.java, compiles fine and then run it. It runs fine and this time hello and hi gets printed in the different lines. We already seen this program. We have printed the Sanskrit alphabet Om. Om is the spiritual alphabet for Hindus. 2384 is the Unicode of character Om. I encourage you to print your favorite character and provide the information about character, language, Unicode and pronunciation of that character in the comment section below. These are some differences between using hexadecimal integer literal and using Unicode character literal. Hexadecimal integer literal is an integer constant, but Unicode character literal is a character constant. While writing hexadecimal integer literal, you can have any number of preceding zeros, but the zeros should be after 0x. You can write 0x61, you can write 0x061, you can write 0x0061, or more number of zeros you can write between x and 6. All have same effects. But while writing Unicode character literal, you cannot have less than or greater than the 4 characters. Means writing the \u0061 in between the single quote is okay, but writing \u061 in between the single quote is an error. Also writing extra 0 between \u and 61 is an error. For the alphabetic characters in the hexadecimal integer literal like ABCDE, capital and small letters does not matter. Means writing 0x small b, 0x capital small b, 0x0 capital A capital B all are same. In the case of Unicode, also the case of the alphabetic characters does not matter. Means you can write capital A to capital E, small a to small e, all are same. While writing the hexadecimal integer literal, x in the 0x can be capital or small. But we cannot use the capital U as \u in the Unicode character literal. That's all for this video guys. Don't forget to like and share this video. Subscribe this channel if you are new. Leave your valuable comments in the comment section below. Thanks for watching.